In the beginning, there was no light, no matter, not even space as we know it. All that would become our universe was compressed into an infinitely dense, infinitely hot point, a singularity. At this moment of creation, 13.8 billion years ago, the familiar laws of physics break down. Time and space themselves are thought to have begun here. From the moment the Big Bang began up to 10 to the minus 43rd seconds, the smallest slice of time physics can describe, the universe was in an unimaginable state. Temperatures surged above 10 to the 32nd power Kelvin. That's 100 nonillion degrees. The four fundamental forces of nature were unified. Then, gravity separated. The first crack in the unified force marked the end of the Planck epoch. At around 110 to the minus 36 seconds, a dramatic phase transition triggered cosmic inflation. Space expanded faster than the speed of light. The universe increased in volume by a factor of 10 to the 78th. This stretch of space seeded the structure of galaxies. Inflation ended at 10 to the minus 32nd seconds. Energy was released, flooding the universe with particles and radiation. This was the real bang of the Big Bang. As the universe cooled to trillions of degrees, a slight imbalance between matter and antimatter occurred, a process called baryogenesis. For every 30 million antimatter particles, there were 30 million and one particles of matter. That tiny surplus became everything. Quarks combined into protons and neutrons. Electrons and positrons annihilated, leaving just enough electrons to form atoms later. By 1 second after the Big Bang, the universe was filled with protons, neutrons, electrons, photons, and neutrinos. At about 3 minutes, temperatures fell to 1 billion degrees. Nuclear fusion created helium, hydrogen, and traces of lithium. This period of Big Bang nucleosynthesis set the chemical makeup of the cosmos. But the universe was still a glowing fog. Free electrons scattered light, making space opaque. Then, 380,000 years after the Big Bang, temperatures dropped to 3000 K. Electrons joined nuclei to form atoms. This era, called recombination, allowed light to travel freely. That ancient light is the cosmic microwave background, still detectable today. The universe entered the Dark Ages. No stars had formed yet, just vast clouds of hydrogen and helium drifting in silence. 200 million years later, gravity ignited the first stars. Massive, bright, and short-lived, they ended the cosmic darkness. They formed the first galaxies and began the process of ionization. The universe was now lit from within. From a singularity to stars, this was the end of the beginning.